Welcome back, section 2.8, continuing on our discussion on inequalities. And now we're going to discuss the rule, what happens if we have an absolute value of the inequality of the form absolute value of ax plus b is greater than c. Well, again, let's make a stipulation right here. This could be for any real number c this time, right? It doesn't have to be a positive value, but mostly we are going to deal with this sort of situation as long as we let c, the constant, be some number greater than or equal to 0. And to test that, you might try dealing with something that's not greater than 0. You might try putting in a negative number to see what could we say about that. Again, I'm going to leave that as an open question for you to explore. But in this case, if we say that c is greater than or equal to 0, the absolute value of ax plus b is greater than c, means that we should handle this as a compound inequality. And we're going to say, then this rule states that we're going to take the value ax plus b out of the absolute value brackets and say that it is less than negative c, or as a compound inequality joined by the word or, ax plus b is greater than positive c. So that's our rule. Anytime you come up across an inequality like this, that's how you handle it. What do we, how does this work out in sort of a basic form? Well, let's try it with some numbers here just really quickly. Let's say I told you this time that I had the absolute value of x was greater than 2. What does that mean to me? On my number line, if I take 0, I take 1, I take 2, I take 3, I take 4, and so on down the line. I say, well, what numbers would satisfy this inequality? Well, certainly, any number to the right of 2 is going to make this a true statement, right? Because if I put in positive 3, sure enough, the absolute value of 3 is greater than 2. If I put in 4, the absolute value of 4 is greater than 2. If I put in 2.01, the absolute value of 2.01 is greater than 2. But are there any other values? Well, sure. Let's go to the left. Negative 1, negative 2, negative 3, negative 4. So let's take values that are to the left of negative 2 this time. Values to the left of negative 2 certainly fit the situation. If we put in negative 3, well, the absolute value of negative 3 is 3. That's greater than 2. Same thing with negative 4, and so on. So all of these numbers to the left also fit. So what have we just established? Well, we've established that either x can be less than negative 2 or x can be greater than 2. And both of these work as solutions to this set. So in this case, the rule absolute value of ax plus b is greater than c divides into a compound inequality joined by the word or. All right, let's give it a shot. Let's say we've got the absolute value of 3x plus 2 is greater than or equal to 3. How do we handle it? Well, again, we rewrite it by eliminating the absolute value brackets. So we're going to take 3x plus 2, set it less than or equal to negative 3, or, join that word or, 3x plus 2 must be greater than or equal to positive 3. And we solve our two equations or inequalities normally now. So let's subtract 2. Subtract 2. We're going to get 3x is less than or equal to negative 5. In this case, dividing both sides by 3, we get x is less than or equal to negative 5/3. Or we get 3x plus 2 is greater than or equal to 3. Subtract 2 from both sides. This time, we find that 3x is greater than or equal to positive 1. Divide both sides by 3. And we get the inequality x is greater than or equal to positive 1/3 this time. Okay? In set builder notation, we can use the word or there. We can write the set of all x such that x is less than or equal to negative 5/3, or x is greater than or equal to positive 1/3. Both act as equivalent solutions to this inequality. Well, in fact, we are asked to put this in set builder notation, but let me just quickly show you that we could also write it in interval notation if we were asked. And if we were to put it in interval notation, here's how it would look. We would take our inequality from negative infinity to negative 5/3, and since we're including that endpoint, we would put a square bracket around it. The word or is equivalent to the symbol union, recall. So we would put positive 1/3 in a square bracket and positive infinity on the other side. So this would be the equivalent statement in interval notation, just in case we're asked that. All right, one more here. Let's try 5x plus 3 is greater than 8. Well, rewriting. That means 5x plus 3 is less than negative 8, or 5x plus 3 is greater than positive 8. So we split it up into a compound inequality, solve our inequality. So I'll just run through it here. Subtract 3, 5x is less than negative 11. Dividing both sides by 5. X is less than negative 11/5. Or subtract 3, 5 times x greater than 5, divide by 5. X is greater than 1. And again, set builder notation requires that we use the curly brackets and use x such that x is less than negative 11/5, and it's okay to leave the fractions in improper form. In fact, we prefer it. X is greater than 1, and that's our solution set to this inequality. One more application in the next video. Good luck.